Everyone, hope you're doing well. I'm not able to be in class today. I have a teacher training thing that I'm attending. So, this is the lesson that I would have given you had I been there in person. So, quick review from the lesson on the snow day, which I hope you had a chance to watch. There's a video on lesson 4.1. But just as a really quick review, we classify numbers into different groups that basically match how we discovered those numbers. So, the first numbers that people used were 1, 2, 3, dot, 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 dot. Right? And then we developed the concept of zero. Now we have the numbers 0, comma 1, 2, comma 3, dot, 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 dot. Now this first set of numbers, we call these the natural numbers. These numbers that have 0 added to them, we call the whole numbers. And then we discovered a whole new set of numbers which have positives and negatives. These ones are called the integers. So -3, -2, -1, 0, 1, 2, dot, 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 dot. These numbers are the integers. But we sometimes have to deal with numbers in between 1 and 2, or -7 and -8. And these numbers are called the rational numbers. And rational numbers are any positive or negative fractions and a lot of decimals. For example, 0.25 is rational because we can express it as 1/4. And 0.333 dot, 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 dot is rational because we can express it as 1/3. Now there's another bunch of numbers called irrational numbers. Numbers like pi, square root of 2, square root of 7, e. We can't write these numbers as fractions. They're just numbers that go on and on and on forever and ever. They're crazy decimals that go on forever, and they never repeat in any sort of real predictable pattern. Now all of these are the real numbers. Real numbers consist of your rationals and irrationals, and all the things in between. Okay, so for example, the number 7 is an integer. It's also a whole number. It's also a natural number. It's also a rational number because we can write it as 7/1. So 7 fits into all of those different categories. Okay, so with that as background, let's go ahead and jump into the notes. You should have received the notes that have been passed back to you. Let's go and take a look at those now. Okay, so here we're going to classify these different types of numbers as natural, whole, real, all that kind of stuff. And let's mark this up. Okay, starting with the number 2. Number 2 is a natural number, it's a whole number, it's an integer, it's a rational number, it's a complex number, it's everything. Now, -1/2, because it's negative, it can't be natural, it can't be whole. Integers can be negative, but integers can never be fractions. I mean, it could be like 7/1, but no like real fractions. Okay, so here it actually doesn't fit anything besides rational and complex. In fact, complex is going to be satisfied by all of them. This next one, 0.6, means 0.6666666. We can write this as 2/3. So it's not natural, it's not whole, but it is a rational number, just like -1/2. Pi, not natural, not whole, not an integer, not rational. 0 is not natural because people didn't use zeros for a long time. So we call this whole. It's an integer, it's rational, it's complex. Square root of 7, that's irrational, doesn't satisfy any of these. 3i is a complex imaginary number, but it doesn't satisfy any of these. -17, it's can't be natural because it's negative, can't be whole because it's negative, but it is an integer, it is rational. This one, purely complex. Square root of 81, trick question, square root of 81 is 9. So we're going to say that's natural, that's whole, that's an integer, that's rational. And square root of 1/7 is going to be a crazy decimal, and so it's only going to be complex. Okay, now that's just review from the snow day lesson. Hopefully you've had a chance to go into Canvas and do lesson 4.1. If you haven't, please do that tonight. All right, let's now go down here and we're going to talk about some rules for exponents. Now, there's one basic rule for exponents that I want you to remember. I don't want you to memorize a bunch of rules, but I do want you to memorize this one basic idea or definition of exponents. The number 3 right here tells you how many times you repeat this guy, which is the base. So 5 to the 3rd means we write 5 out 3 times with multiplication signs in between. A to the 6 means we copy and paste A 6 times with multiplication signs in between. Let's go now over here. Do this one on your own. Q to the second. That's right. QQ. Okay, moving along. One thing to remember is that the exponent only applies to the number that it's attached to. So this is not AB, 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 AB 4 times. This is A, B, the letter B, copied and pasted 4 times. 1, 2, 3, 4. Same thing with this. This is 2 with the letter A, copied and pasted 3 times. QM to the third, Q, M, M, M. Now, if you do want the exponent to apply to 2 or more things, you have to put those things in the parentheses. Now, this 4 applies to the whole chunk inside the parentheses. So that means AB, 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 and AB. I'm copying and pasting AB 4 times. Now, because the order of things doesn't really matter in multiplication, we can rewrite this as A, B, 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 which is A to the 4th, B to the 4th. Same idea here. 2A cubed is 2A, 2A, 2A. I'm copying and pasting this 3 times. All right, that's 2 times 2 times 2 times A times A times A, which is 8, A to the 3rd. 2 times 2 is 4, 4 times 2 is 8. Okay, this next one, QM cubed, Q to the 3rd, M to the 3rd. Taking a little shortcut there. You guys follow me, right? Okay, let's go on down and do the next page. If I can get this thing to work. Okay, so the first idea here, the first concept, is we are multiplying two numbers with the same base. Remember, the base is the number on the ground, touching the ground, the base. So 5 to the 3rd, this is 5 times 5 times 5. 5 to the 2nd, this is 5 times 5. There's a multiplication sign in between, and when you look at it this way, you say, oh yeah, it's 5 copied and pasted 5 times, so it's 5 to the 5th. Same thing with this one. Let me color code this just for fun. A to the 6th means 1, 2, 3, 4, 5, 6 A's. This one is A. And so how many A's do I have? I have A to the 1, 2, 3, 4, 5, 6, 7, A to the 7th. This one, Q to the 2nd times Q to the 5th, QQ, Q, 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 and that's going to be Q to the 7th. Okay, so what rule can we describe for multiplying numbers with the same base? How do we get 5, let me circle this, how do we get 5 from 3 and 2? How do we get 7 from 6 and 1? How did we get 7 from 2 and 5? And if you're thinking you're adding the exponents, then you are exactly right. We add the exponents. So let's think of this same thing with symbols. So with symbols, we might say something like, I'm just picking a random letter. Let's pick A to the M times A to the N. These bases, remember, are the same, is equal to A to the adding exponents means M plus N. So that's the rule written in symbols. But just the idea is you can always go back to writing exponents out the long ways and then following that pattern. Okay, next idea, dividing numbers with the same base. So here we got 5 to the 5th, which is 5, 5, 5, 5, 5 on the bottom. We've got 2 of these. And now remember the rule, if there's something on top of a fraction on the bottom, we can cancel. 5 divided by 5 is just 1, which doesn't affect the value, so we can just ignore them. 5 divided by 5 is 1, just ignore it. And we're left with 5 to the 3rd. Same thing for this one, A to the 4th, A on the bottom, canceling them out, A to the 3rd. Right here we've got Q to the 6th, 1, 2, 3, 4, 5, 6. We've got 1, 2, 3, 4 on the bottom, and we're gonna cancel, 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 and we're left with those 2 survivors on top, Q to the 2nd. Okay, so we need to come up with a rule for what we're doing here. And the rule, let's look at this. What are we doing here? We got a 5 and a 2, and it turned into a 3. A 4 and a 1 turned into a 3, and a 6 and a 4 turned into a 2. And if you said subtract the exponents, then you are exactly right. So when we multiplied, in our previous example, we add the exponents. Now here, when we divide, we subtract the exponents. And let's come up with a rule for that using some symbols. If we wanted to make a rule for this using symbols, we would say something like this. Let's say a to the m divided by a to the n is equal to a to the m minus n, subtracting those exponents. Okay, so let's talk about the 0th power for a second, because you'd think, or at least I used to think, that something to the 0th power would be 0, right? You write something 0 times, there's 0 of them. But the truth turns out to be a little bit different. Now let's take a look at these examples here. 5 to the 5th over 5 to the 5th. Well, if we multiply this out, or if we write this out, 5, 5, 5, 5, 5, on the bottom, 5, 5, 5, 5, 1, 2, 3, 4, another 5. And what is that going to be? Well, we can start canceling these things out. That cancels, that cancels, that cancels, that cancels, that cancels. And you're left with, well, what are you left with when everything cancels? Well, let's do something simpler. What if you had something like 5 divided by 5? You have $5 divided by 5 friends. Each friend gets $1. Or 10 divided by 10 is 1. In fact, anything divided by its twin on the bottom is equal to 1. So this is equal to 1. A to the 4th over a to the 4th. This is 1. Same thing on the top and the bottom is going to be equal to 1. So all of these, this next one is equal to 1. But remember that rule we had before? So the rule we had before is something about subtracting exponents. So if we remember that rule, it would be something like this. If it was a to the 10th over a to the 3rd, then that's going to be a to the 10 minus 3, a to the 7th, subtracting exponents. Well, let's apply that to something like this. If we did this, that's going to be a to the, circle this, 4 minus 4. A to the 4 minus 4. And 4 minus 4, well, that's just 0, a to the 0th. But we know that this is equal to 1, so a to the 0th is 1. 5 to the 0th is 1. Q to the 0th is 1. In fact, anything to the 0th is 1. Okay, so that's the rule. Pi to the 0th, 1. In fact, 0 to the 0th is also 1, which is kind of nifty. Okay, so now let's talk about negative exponents. Okay, so negative exponents. Where do negative exponents come from? Well, let's first of all simplify this out. Without using any fancy rules, let's just use our definition of exponents. 5 to the 5th means we copy and paste 5 times. So it's going to be 1, 2, 3, 4, 5. 5 to the 6th means we copy and paste that 6 times. Now, when we start canceling things out, most of these 5s will die. Those die, those die, those die. There's going to be just one survivor. And that sole survivor lives on the bottom of the fraction. So we can rewrite this now as 1/5. We can also use our fancy rules of exponents, and we can write this as 5 to the 5 minus 6. 5 minus 6 is -1. So 5 to the -1 is equal to 1/5. All right, let's apply a few more of these and see what pattern we see here. A to the 4th, 1, 2, 3, 4. A to the 7th, 1, 2, 3, 4, 5, 6, 7. When we start canceling, there's going to be how many survivors? You got it? 3 survivors. They're all on the bottom. So we can rewrite this as 1 over a to the 3rd. Well, what if we use our fancy rules of exponents? That's a to the 4 minus 7, which is a to the -3. And there you have it. A to the -3 is the same thing as 1 over a to the 3. Taking a look at this one, q to the 0 minus 1 is equal to q to the negative 1. And if we simplify this thing, q to the 0th, that's 1. Q to the 1th is q. And so I know that's messy, but that's just going to turn into 1 over q. So 1 over q is going to be equal to q to the negative 1. All right, so if that's confusing, let's do a few examples, and those examples hopefully should make you completely unconfused. Okay, so we're going to rewrite each of these with some negative exponents. So 1 over 5 to the 6 is the same thing as 5 to the negative 6. Okay, just follow this pattern. 1 over a to the 7th is a to the negative 7. So a positive exponent, if it's on the denominator, becomes a negative exponent. One last one here. This is going to be q to the negative 9. All right, now let's go the other direction. If you see a negative exponent, what that really means is you are dividing by a to the 3rd. B to the negative 7 means you're dividing by b to the 7th. 2 to the negative 1, well, that means you're dividing by 2 to the 1th. And in fact, that's just 1/2. Okay, so let's go ahead and do these fun problems. 1 over 2 to the negative 3. Well, here we can actually do this. 1 is the same thing as 2 to the 0th. So that's 2 to the 0th minus what? Minus that thing, which is negative 3. A negative and a negative are going to turn into a positive, and that's going to be 2 to the positive 3rd. All right, so do that one more time. You saw 2 to the negative 3 on the bottom. A negative exponent on the bottom will turn into a positive exponent, like that. Okay, this next one, this is going to be 2 to the 2nd minus 3, which is going to be 2 to the 2 plus 3, 2 to the 5th. Okay, this next one, go ahead and give this one a try. Okay, a to the negative 5 minus 1, a to the negative 5 plus 1, a to the negative 4. Okay, so all we're doing here is we're following that same rule where we're subtracting exponents. Let's just do a simple example just in case you're feeling confused. The simple example is this. A to the 10th over a to the 2nd. This is a, 10 a's, a on the bottom. And if we cancel 2 from the bottom, then that 10 now is 2 less than it was before. So that's a, 2 less than it was before, a to the 8th. So we're subtracting exponents. That's all we're doing. Same idea here, in case this looked confusing, it's just the same idea, but with some negative numbers involved, but the same principle. A to the negative 5 minus negative 1. And we flip those signs and you get negative 4. So it's the same concept, just the negatives look a little crazy. Okay, this next one, I'm just going to go through this last one kind of quickly. This is just, actually second to last one quickly. This is just a cool little trick that might come in handy. So here, if you have a fraction raised to a negative power, one easy way of simplifying that is if you flip the fraction upside down, now you can make that a positive power. And I won't go through how to prove that because I want to make this video as short as possible. But just remember, b to the m to the negative 3rd, I don't want that negative 3rd. I want it to be a positive. The way I do it is I flip the fraction around. And it kind of has to do with negative exponents, making things that are on the top want to be on the bottom, making things that are on the bottom wanting to be on the top. And that's basically, in a nutshell, why that's flipping around. Okay, the last one is a lot more important. Let's talk about this. Here, how do you simplify a to the 3rd squared? Well, again, if you don't know what to do with an exponent, the best plan is to go back to the most basic idea of what exponents are. This right here is something, and we are copying and pasting it 2 times. So the instructions this is giving us is copy this thing in the black box twice with multiplication signs in between. So a to the 3rd, a to the 3rd. Well, a to the third is a to the third is a, so this is a to the 6. Okay, let's look at this one. B to the 4th to the 3rd. This is telling us we need to copy b to the 4th 3 times. So b to the 4th, b to the 4th. We're just following those instructions, copying and pasting that base, b to the 4th, 3 times. And then b to the 4th is b, 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 right? And we have 3 groups of 4, which is going to be 12. So this is b to the 12. This one, a to the 0th, copy that twice. A to the 0th, a to the 0th. Hang on a second, anything to the 0th is 1. 1 times 1, 1. So that's going to be 1. Okay, so how do we get there? What rule can we come up with this? We had 3 and 2 turn into 6. We had 4 and 3 turn into 12. And if you're thinking multiplication, you are exactly right. We are going to multiply those exponents. Okay, so let's write this using symbols. If you have a to the p to the m, that's going to be a to the pm. Now, I just want to stop for a sec, just in case you're getting confused, and show you the difference between a couple of things that are all quite different from each other. Let's say you have this, a to the 3rd times a to the 2nd. Actually, let's do real numbers. Let's do 3 to the 3rd times 3 to the 2nd. And let's over here talk about this one. Let's do 3 to the 3rd to the 2nd. That's our next problem. And then over here, let's do something different. 3 to the 3rd plus 3 to the 2nd. Let's see how these are similar, how these are different. Now, the best way to proceed, if you don't know right away how to proceed, is to remember the definition of exponent. You're going to copy and paste this number 3 times. So 3 times 3 times 3. Going to copy and paste this 3, now only 2 times. 3, 3. There's a little dot in between, so that dot goes there. Well, now I have 3, 3, 3, 3. A bunch of 3s strung together with multiplication signs, and that looks like 3 to the 5th, which is the number 3 copied and pasted 5 times. Okay, this one, 3 to the 3rd to the 2nd. Is that the same? Is that different? Well, remember the definition. This tells us how many times we write 3 to the 3rd. So we're going to write 3 to the 3rd twice. Well, that's going to be 3 times 3 times 3, 3 times 3 times 3, which is going to be 3 to the 6. So in this case, we are adding. In this case, we are multiplying. And this last case, what do we do here? Well, remember, let's write this out the long way. This right here is going to be 3 to the 3rd, which is going to be 3 times 3 times 3. I don't know what to do with that plus, I'm going to write it down. 3 squared is 3 times 3. 3 times 3 times 3, 27. This is 9. And it's actually going to be 36. I can't do anything clever with those exponents, like turn it into 3 to the 5th or subtract or anything. I just have to follow the order of operations and crank that out. Okay, right now what I want you to do is to go in and start your homework assignment. The homework assignment is 4.2. It's on Canvas. Right here. Let's see if I can, what's going on here? Do, 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 do. Okay, so this is it. Assignment 4.2, exponents. And go ahead and jump in here and start solving these out. Let me just go over a couple of points here. One thing is about entering things. Let's skip to question 2. If you guys can log in to your Chromebooks and maybe pause this video or come back and watch this later. I will post this on Canvas, but here's what I want to focus on is this thing right here. It's just about entering stuff into this program. It's kind of annoying. Okay, so right here, You got v to the k over v to the h. V to the k over v to the h. And we know that when you divide things with the same base, you subtract the exponents, and your answer is v to the k minus h. The problem is that when I try to type that in, v to the k, when I press the minus sign, it makes a big minus down here like that. We don't want it like that. We want it v to the k minus h up here. So the way to get around that is when you type this in, do v raised to the parentheses k minus h. And that should save you. Now, another thing that people get stuck on is this question, 2 to the 6 minus 2 to the second. Remember, you can't do anything tricky with the exponents here. You just have to solve this guy out. So you have to do 2 to the 6 minus 2 to the second. So on your calculator, hit 2 to the 6, get a number. On your calculator, hit 2 to the second, or you can actually do that in your head. 2 to the second is 4. And this number, 2 to the 6, which I think is 64. 64 minus 4 is 60. Your answer is 60. So here, you can't write 2 to the 4th. That is not right, because that would only work if it was like 2 to the 6 over 2 to the second. Then you could do 2 to the 6, 2 to the 6 minus 2. But you're not dividing. You're just doing this question. And again, there's no clever trick you can do with combining exponents. You just have to evaluate that, turn that into a number, turn that into a number, and subtract, and just kind of do the kind of arithmetic to get the answer. Okay guys, I hope you had as much fun watching this video as I did making it. Remember, the assignments that you need to get done are 4.1 and 4.2, and I'll see you all on Tuesday.